Okay, and then acetylcholine, some of it is being broken down by this acetylcholine esterase, this ACE, right? But some of it is actually reaching postsynaptic membrane targets. And of course, the postsynaptic membrane targets of a neurotransmitter are the receptors. And unlike the monoamines that we've discussed so far, right, dopamine and norepinephrine, there are both metabotropic receptors and also ionotropic receptors for acetylcholine. So acetylcholine has receptors that will respond to the binding of a neurotransmitter with a change in shape, right? That will open a channel or open a pore to allow for ions to pass through. Specifically, sodium comes in. Some of them permit actually sodium and calcium to come in. But if you think about it, if we have a postsynaptic membrane at the resting potential of -65, right? And you open channels to sodium, right? Or even calcium as well. And this stuff rushes in, right? Driven, of course, by our concentration gradient force, right? And our electrical force. Well, you're going to depolarize this cell. You're going to actually take it towards the threshold for the initiation of an action potential. So this allows for a sort of fast, conversion of this chemical message into some kind of, electrical message in the postsynaptic cell. Okay, and this is going to become important. There are also, of course, receptors that are metabotropic that can influence, the gene expression and protein synthesis as well. So there are receptors that are both ionotropic and metabotropic. Don't panic about the names, but pay attention to this one. Nicotinic receptors. Obviously, there's going to be a drug there that'll influence this particular class of receptors. Nicotine acts at these ionotropic acetylcholine receptors. They're called nicotinic receptors.